Good morning. I am Dr. M. Sreedhar, Professor in Electronics and Instrumentation Engineering, VNR Vignan JYOTHI Institute of Engineering and Technology, Hyderabad. Let us continue the lecture related with power plant instrumentation. We have already studied the overview of power plant, where number of units such as the boiler drums, feed water systems, steam, fuel and air systems are associated. Today, once again, let us see the overview of this with the help of a diagram, and then we will continue what are water and other circuits related with steam and water lines. Here you can see thermal power plant, how it is connected with a heat exchanger and condenser, generator, turbine and all these systems. These are having different pipelines. However, the cooling tower is also represented here. Let us in detail study about this thermal power plant with the help of a layout. You can see here, this is the boiler. So here you can observe different lines such as the feed water. This is the feed water line, and this feed water line is coming via a economizer. So this economizer is coming from a LP, low pressure heater, and here another one is HP or high pressure heater is there. And before that you can see a water treatment plant. This is the water treatment plant, and to this water treatment plant, the raw water, this may be coming from say the rivers or any huge water sources. So from this raw material or raw water that is sent to the water treatment plant. Here there are more number of analytical instruments associated, because the water is an important source for a power plant also, in addition to the fuel, because the water is required with a quality water. So in order to get the quality of water, we need to remove salts, inorganic matter and other substances or contents present in the raw water. So these are to be removed. For that purpose, we need this water treatment plant. What are the instruments present here? Particularly there are some electrochemistry subject that is related with this. That means sometimes we need to analyze the pH, the conductivity of water, and sometimes salinity and TDS, total dissolved solvents. All these things need to be treated with the help of this water treatment plant. Then this particular water is pumped through a low pressure heater. Here is a heater, and another important one is economizer. Here I will write economizer. So economizer purpose is that will supply the water with the preheated temperature, because the raw water is not having sufficient temperature before sending to the boiler. Economizer is very much important, and one doubt you may get this: how we will get the temperatures or energy or heat energy to the economizer? Yes, this heat energy to the economizers is coming from flue gases of furnace system. So whatever the gases that we don't have interest or need to send via the chimney through the atmosphere, these gases are also having certain temperature. So without wasting the temperature or the energy of these flue gases, that we are diverting towards an economizer. So for that purpose only we are using this economizer. So for example, the raw water is having a temperature say 26 degrees centigrade, and you can heat this up to say 50 or 60 degrees centigrade, because the temperature that we collect from the flue gases may be at that level. So extra energy only we need to supply to generate the steam. In that way we can save the fuel that is required by the water to generate the steam. So ultimately this raw water is flowing via an economizer, which can give before some heat before entering to the boiler. Now the water is entered into the boiler. So water is entered into the boiler, and here what we require is the combustion. Anything to heat, we need first of all to start the ignition, or the combustion system will start. So for that purpose we have fuel. This fuel section, this is nothing but fuel handling unit. Depending upon thermal power plant and availability of sources, some plants may be related with coal. So this may be again different bituminous type of coal is also there. And some plants which may be utility plants, like the food industry is there. Suppose they want to start a boiler for their own utilities, at that time they may use some of the unwanted raw material to burn to generate the combustion system. For example, rice mills, particularly we have rice husk is there, more number kgs of rice husk that can be utilized as a energy source. So after firing this, or after making combustion, this one more important thing is this combustion deals with the supply of air also, because air and fuel both are to be controlled in a proportion in order to get combustion. That's why another unit is FD fan. This is nothing but forced draft fan. This forced draft fan, from atmosphere it will take the air, and this air is being sent to the air preheater. This air preheater is also getting some of the temperature from these flue gases, because this air is to be sent to the combustion system in a purified dried form. If any wetness is there, that is not being utilized for the perfect combustion. Therefore we need a preheater also. So we are sending the combustion air. This combustion air and the fuel both are giving a combustion onto this boiler. So water inside this will heated with the help of this combustion, and later it will generate a steam, which was indicated like this. So this is the steam, and finally the generated steam will impinge the blades. Like this we have some propeller or blades of the turbine. So here these blades will receive the high temperature, high pressure steam onto this propeller or the blade. So whenever it is rotating with high speed and with the electromagnetic principles, the generated power will be generated. We know well about all these electromagnetic principles, and later it is distributed. That is the duty of electrical engineers. Another one is the steam upon generation will be cooled by sending cooling waters onto the turbine system and turbine pipelines. There the steam will be cooled down and becomes as water. This water is nothing but a condensate water. So this condensate water, without wasting any content of the condensate water, we have to recirculate this and to add up with the raw water. And here this is, so here we have turbine and condensate water that is reaching to this condenser, and water will be reaching here, and this is circulated with the help of this will added with the makeup water, and this makeup water and both will give you the feed water to the boiler. So in this way finally the thermal power plant functions. Now what are various aspects related to this I and C in water circuit? Condenser. This condenser is using the untreated cooling water. As I told you in the diagram, this will sends a condensate for the condensation purpose. So one is the feed water and steam flow circuit, another one is cooling water flow circuits. So particularly we have two types of water circuits present. One is water side and steam side. Another one is cooling water flow side. In addition to that, we have another important aspect is boiler feed water circulation. This boiler feed water circulation is necessary because the water is to be sent to the boilers at the defined specifications, such as if we are unable to send this water to the boilers without any proper specifications of flow rates, then it may leads to give you sometimes the blast of a boiler. Therefore, water tubes are connected between the boiler drum in top and header as I indicated. Here in the last class I have indicated how this boiler drum is connected with the header. So yesterday I have drawn a diagram in the last class. So this is the boiler drum and these are connected to the header. This is header. So in this way these lines, parallel lines are connected. So this is what describing. And water is circulated within the tube. So these water droplets are coming and circulated like this, and the steam converted and sending via these pipelines. For this purpose we have set up pipelines. The rate of steam formation is directly related to the water circulation rate. Yes, we have to follow this particular rate of steam formation must be in such a way it should be related to the water circulation rate. Then only a boiler will be safe and it will not create any harmful or any hazardous situations in the power plants. Now boiler feed water circulation. The circulation rate must be sufficient to remove the heat from the tube surfaces. Yes, continuously the water must be circulated in such a way to remove time to time heat. Otherwise the heats will get too much heat. If the water circulation is very slow or sluggish manner, then burnout problem happens into the boilers. And large bubbles formation that may causes sometimes biggest blast or burning of the tubes. The water movement must be in one direction only. The natural circulation. So this natural circulation is done by the gravity force. So this is one kind of circulation of water into the boilers. And forced circulation by employing some pumps and combination with both also. That may be the forced as well as with the help of some pumps also we can circulate it. Natural circulation and critical ratios. So there are differences in densities in water in the downcomer, that means header, and steam water density in the riser circuits. So therefore we need to send the water at a proper circulation rates. Therefore when we generate the steam from the boiler, there is some mixture of water and steam and density is lower. That is due to the heat absorption in the riser. So lesser density saturated steam is delivered to the boiler. The combination of lesser density water is given. Another one is natural circulation and a critical ratio. In boilers, this ratio is very important. So that is defined as the ratio of steam and water mixture flow rate to the amount of steam that is generated or produced. So based upon this critical ratio, the flow and circulation of water into the boiler will be adjusted. Forced circulation is one category of circulation where it utilizes external pumps in order to forcefully send the water or the steam through the boiler circuits. It is sometimes called as once through water circulation. So once through water circulation is nothing but forced circulation. Another one is combined circulation. This combined circulation utilizing the force gravity by means of pumps. As indicated here, the first feed water is converted into saturated steam in combination in the combustion chamber area and then to the superheater steam. The feed water supply is also an important aspect because we know well how the feed water is being supplied to the boiler with the overview diagram. This is the feed water supply. Chemical condition of feed water is estimated. As I told you, this chemical analysis or analytical instruments will come into picture for the analysis of conductivity, dissolved oxygen, pH meters. Here is the list of various waters also present in the boiler. We can categorize these waters into 4 ways. One is the raw water, another one is boiler water, feed water and blowdown. So these 4 are playing a greater role in boiler instrumentation and boiler operation. Let us see what a raw water is. Raw water is nothing but the natural water with some sort of impurities as the earth has originally endowed it. For example, we have ground wells as indicated here. This is the ground well is one example of raw water because it is also available as springs and wells. Sometimes surface waters, the streams and lakes are also given as example of raw water. Next, the importance is clarification and softening related to the boiler water. Softening is nothing but removal of dissolved water. If we are unable to remove all these dissolved solids, that may be given as high contamination or it may produce high contamination within the boiler vessels. Consequently, the quality of the boiler vessel and internal parts of the boiler will also be damaged. Another one is the clarification. We need to remove the turbidity parameter associated with this. The boiler water and feed water. The boiler water, it is the actual liquid content of the water. Another one is boiler water that is introduced to replace the evaporation. So these all the waters are very important. Another one is blowdown. This blowdown is nothing but the draining the water from the boiler because almost all the waters are collected at one place and that is called as a blowdown tank. Here there are 2 kinds of blowdown tanks are there. One is the CBD and another one is the IBD. So CBD is nothing but a continuous blowdown. Another one is intermittent blowdowns. So we need to drain the water from the boilers. So it may be greater or equal impurity content than the boiler water. So it has to be drained. Normally this will comes under the pollution treatment. We need pollution treatment because the CBD or IBDs are having more polluted water. This polluted water, again to reuse it, we need to treat, or even though it is sent to the atmospheric spheres or to the rivers as drain, because all the fishes and other aquaculture is living in the rivers. If we send the drain water from these boilers or thermal power plants, the life of those aquaculture may be less, may be reduced. So therefore, to do not make any harm to the aquaculture, we need to treat. That's why we will use scrubbers. Scrubbers are the equipment used for treating the pollution related liquids. So when we use scrubbers, associated with the scrubbers, other equipment also used, and we will treat well. And finally, upon deciding the wastewater that is contained in the blowdowns tanks is safe zone limits, then only that safe zone limit liquids can be drained out into the rivers or into the any other kinds of things. So all the chemicals that enter the boiler through the injection of the boiler remote to the blowdown. So this is the importance of blowdown. And mathematically also we can calculate the blowdown flow. How it can be calculated? Feed water flow and concentration ratio we will take as a measure. So this is all about various waters present in the boilers and how to drain out and what are the equipments that we can use to treat the water. So this is all about the water related. We'll meet in the next lecture with the other content. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.